machine learning that we can add into our machine learning models. But in general, what we'll be doing with ML is taking historic data and making predictions on new data. So for the data scientists, there's a typical workflow that often happens for basically any machine learning workflow or problem. And after understanding what your use case is, the first piece is data integration. So what pieces of data, what types of information do we want to bring together? For lead scoring, we'll talk about this in detail more, but this would be information about your customers, things like what company they're from, the size of the company, what role they have. You might also want to have behavioral information like how often they visit your website or what types of pages they look at. Once having your data somewhat prepped together, usually in a tabular format, there would be some exploratory data analysis or feature engineering that was done. So how do we join the different data sets together? How do we extract information out of data sets? A lot of machine learning algorithms sort of require numeric data. So you might need to handle categorical or date values or massage your data so that it works in machine learning algorithms. Then we actually have the model building process where we're trying different types of algorithms to make some sort of prediction. Often while building these models, we end up going back to the data integration or the feature engineering phase to add in new features or to modify our data set. And every time we build a model, usually our data scientist is going to be using machine learning interpretability techniques like feature importance or Shapley or partial dependence to understand how the model works. And so this is sort of the data science perspective on what happens when we do different types of use cases. But if we take a step back and think about machine learning for business use cases, this is just sort of the middle math part. And the bookends are probably even a little bit more important. And this is where it comes to communicating with your business user. So what pain points are you actually trying to alleviate? What sort of data are you pulling together matters depending on what kind of use case you're trying to solve. So even lead scoring is kind of vague. We'll talk about different types of specific business problems that could be related to lead scoring. And once we've built a final model, even if you put it in production, how are your business users getting insight out of it? How are they going to understand what the predictions on new data are? Do they need to understand that a binary classification has a value between 0 and 1? Or are we going to present this in a more business-friendly manner? So today we're going to start in our slides to talk a little bit more about the pain points and how a data scientist can talk about specifically lead scoring, but any use case with their business users. And then we're going to do a hands-on workshop where we're going to build a model together, this centerpiece, and then we're going to build a front end for this final piece. How do you present the information to your end users? All right, so let's talk about talking to our data science users. Machine learning problems can really be grouped into 3 types of use cases. We have how much questions, which ones questions, and brand new insights. And in the world of machine learning, this is going to be regression use cases, classification use cases, and unsupervised machine learning. So how much is any time where historically you know what counts were and you want to predict them in the future. So how much electricity is going to go through this substation next month? Or what is the lifetime value of this specific customer? Or how many bicycles of each color am I going to sell in every Walmart in every state for the next 6 months? But these are all how much questions, and we would use regression type algorithms for solving these. For which one, this can be both binary classification or multi-classification, but this is yes or no questions like who's going to default on a loan or will this person pay back a loan? This includes which customer will churn, another yes or no question, but we can also have multi-classification problems like which group does this person belong to, where you know what your groups are ahead of time. So you'd have a labeled historic data and then you're trying to fit new customers into specific groups. Unsupervised learning is where we're doing new data-driven insights. So we don't know historically how much or which one, we just have data and we're trying to learn new things about it. So this could be like anomaly detection. You wouldn't historically know who is an anomaly, but you want to look in your data set and see what's a little bit different than everything else. Anomaly detection can be really good for fraud. We can also look at topic modeling. So you might have a lot of text data like customer reviews, or for lead scoring, you might have a customer fill out why why they're interested in your product, and you want to actually understand what the text is about, but you don't have any labels ahead of time. So you would be trying to pull out or extract topics or word embeddings without knowing what they were ahead of time. And so when we're talking to our business teams, we can understand what type of use case their business problem actually falls into. And for the most part, if it's most productionalized models are going to be regression or classification problems, and we can use the same types of algorithms for that. Our new data-driven insights usually have different types of algorithms that are specifically around unsupervised learning. All right, so we've talked about what our data scientist has to do specifically for understanding business problems. Jason, I'm gonna go ahead and have you mute. But let's talk about some of the other just best practices in general for all types of use cases our data scientists should be focusing on. So the first is talking to the business user and being able to frame these sort of business problems as machine learning problems. And this is how you know what algorithms to look at, what data to start pulling, and basically making sure you're building a model that can actually be used. Then we don't always have the data available that we want to. So do you have the data that you need? Will it be available at time of prediction? Are you going to be able to be building a model which can actually be used in production? And the third point is once we build a model, we want to make sure it's not only good at the predicting on the data we trained on, but is it actually good at predicting on new data? If your goal is to build a model which can predict if new leads are going to be good or not, we need to make sure that it's actually successful at leads it's never seen before. And so this is going to be things like cross-validation or test scores, but it's something the data scientist has to focus a lot on. The next piece would be choosing the right algorithms. So we talked about how regression and classification problems usually have the same types of algorithms. This is going to be things like XGBoost, like GBM, linear regression, but you might choose different types of algorithms based on in your use case if performance, either speed or accuracy, is more important, or interpretability. So for some of our really high valuable use cases like fraud, performance is way more important than being able to explain the model, and you might be okay with a black box. But for other use cases that are in more regulated fields, like predicting whether or not someone's going to pay a credit card, you're going to probably focus more on interpretability and being able to actually explain the models to consumers and regulators. So being able to understand what algorithms rate for a use case is another best practice to focus on. If you're building these machine learning models by hand, you're going to actually have to tune the algorithms. So algorithms have hyperparameters. For example, our tree models build decision trees of different heights. When should they stop? What should the learning rate be? So if you're doing this manually, that sort of iterative process is going to be something you're going to have to do, but we'll be looking at automated machine learning today, so that will be handled for us automatically. But something that the human needs to be a little more involved in is understanding the final model. Do we trust it? Does it make sense what the model was, how the model's working? Do we see any biases in our model? If we were doing something like predicting credit card, would we see a discrepancy in gender or race on predictions? That's a problem. So we really need to understand how our model is working. And then finally is actually presenting these findings in a way that solves that original business problem. And this seventh step is what we're going to be looking at in the second half of the workshop. We're actually going to build a dashboard for consuming our lead scoring prediction model. All right, so we've talked about the data science best practices. So now let's get a little bit more into lead scoring. So for anyone that's not familiar, lead scoring is essentially a methodology for ranking prospects. What's the priority of addressing or prospecting that your sales, marketing, or partner team should do? If someone's interested in your product, how interested are they? How likely are they to be consumers or future customers of yours? And if a specific prospect is likely to close soon, never, in the next year, that type of thing. There's a lot of different types of data we can include for this. Some of it is going to be explicit and usually from the prospect. So what's their job title? What company are they at? You could bring in third-party data, like taking that company and understanding from, say, LinkedIn, what the size of the company was. It's going to be explicit details about the specific customer or prospect. But you could also add in behavioral data. So do they visit your website? What pages are they looking at your website? Do they click through on emails? Are they watching videos on YouTube? Do they interact with you on social media? So the type of user behavior you can bring in is pretty varied. And we would join these data sets together to actually understand how your historic prospects became customers. And the benefits here, it increases the effectiveness and efficiency for several teams. The marketing team, because they know what types of prospects or leads to focus on. The sales team, because they know which types of leads and prospects, which individual prospects they should go after first, which ones are likely to take a lot of time or a little amount of time, and also helps partnership teams for the same reason. And somewhat indirectly, this can increase revenue because your teams are focusing on the right leads that are likely to close rather than sort of a more random approach or treating every lead equally. So probably many people on the phone are doing lead scoring today. You might be using a predictive model, or you might be using a more rules-based approach. So a rules-based approach is going to be based on a human's expertise or a team of humans' expertise who would come up with rules for how explicit and behavioral data should become a specific lead score. So this is all done usually completely manually. The complexity is going to be limited by what a human can think of. And it's going to be sort of, we have the creativity as humans, but also it's going to be maybe more simple rules, not very complicated. They are more likely to be intuitive and make sense to the business, but it's also a way to miss surprising insights or interactions in your data. So for example, we could say that every new prospect starts at a score of 0. And if they ever get to 200 points, our sales team should go talk to them. You could gain points for visiting the website. So every day you can get 5 points for visiting the website. If you go to more than 10 pages, you get 10 points. But maybe if you visit our careers page, you lose 30 points because you're not actually interested in our product. You want to come work at our company. If you download a white paper or watch a video, we'll give you 25. And if your title, your job title is some sort of decision maker, so you're in the procurements team, you have an executive title, then you get 50 more points. This is just an example, but these are the types of manual rules that your business development team or other teams would be building. And this would be applied to every user, probably in a CRM like Salesforce or something else, to actually get these sort of rules-based leads. So how would we do this with machine learning? Well, a machine learning model would take the historical data, probably labeled by your traditional rules-based approach, and then an algorithm would determine the best rules for assigning lead scores. So our algorithm would learn what about the historic data led to a good lead versus a bad lead. Some benefits here are that no one needs to know what the rules are ahead of time. You don't actually have to come up with the rules. You don't have to test if the rules are working or not in sort of a explicit manner. You could test if the model is working or not. But there's also not a limit on complexity. The rules can be very, very detailed. They can aggregate together 600, 700 of different features about your customer all in one rule. And it's really fast to test out new rules or new models. You don't have a human by hand testing out different things. You can quickly build a model and then do predictions to see if your accuracy goes up or not. A potential downside is the rules could be really unintuitive or confusing, which could lead to a lack of adoption by the business teams for the model. And depending on the use case, explainability might be more important to your end user than predictions. So maybe that your sales team doesn't just want to know this is a good lead, but they want to know exactly why it's a good lead. And that could be sometimes a little hard to do with machine learning, although we'll focus today on interpretability for ML. Okay, but we talked here that machine learning for lead scoring is going to require historic data on what's good leads versus bad leads. But what historic data should we use? Well, this really goes back to talking with our business users about what problem we're actually trying to solve. Because our type of problem, we're doing a which one problem, which leads will be good and which leads will be bad, but there's still a couple different business questions we could be asking here. So say we are saying which good leads are good or which leads are bad. We could also ask a different question, which is which of these leads should our top closers focus on? So what are the most leads that are most likely to be big deals? Or we could say, which are leads that look promising, but they're going to take a year or 6 months of nurture time. So a salesperson shouldn't have them yet, but maybe a BDR should. Or we could say, which leads are likely to respond to a cold call email right now. So there's lots of different questions we could ask. And depending on which of these we're interested in, our training data or our label data is going to be a little bit different. So let's say we go with which leads are good and which ones are not. Well, what does good mean? So we could say that a good lead is ones that historically have been a marketing qualified lead or a sales qualified lead based on our own rules. Or we could have our experts like the BDR sales team, we could have them hand label old leads as they came in and then train on that. These leads were good, these ones are bad. Or we could come up with some rules-based approach. We could say any prospect who became a customer within 3 months, that's a good lead and everyone else is a bad lead. Or any prospect who became a customer within a year, that's a good lead, this one's a bad lead. Or any prospect who, as soon as we knew about them, they responded to an email within a week, that's a good or bad. So the point here is that it really depends on what problem you're trying to solve. And if we were to just say, oh, we're going to build a lead scoring model, it'd be easy to make some assumptions about the use case and build something that's not exactly what the business needs. So this is where we want to really focus in on what is a pain point and what are we trying to actually solve. So let's get into our workshop. We're going to talk a little bit on how we would do lead scoring at H2O. So we're going to build a machine learning model using our automated machine learning software called Driverless AI. We're going to use 3/4 of leads data, which has been anonymized. So it's not actually real data, but it's based on real data, just for the benefit of a public presentation. And we're going to say, we're going to do a which one question, and we're going to say which leads are good and which leads are bad. So we're going to only train on leads from the last 3/4, which were either good or bad explicitly and not sort of undecided. So we took a rules plus hand labeled approach where good leads are going to be they MQL'd or they SQL'd or they became customers. And bad leads are going to be they were disqualified by the BDR or business team, sales team, they were labeled as spam, or they said do not call. So we're going to take those historic information and build a machine learning model that we can use on new leads to see if it looks more like a good lead or more like a bad lead or somewhere in between. Once we build that machine learning model together, we're going to look at a custom built front end for this specific use case using H2O Wave, which is a Python library that allows you to really quickly build UIs and front ends using only Python and is a really fast way to build AI apps. So we'll look at an application that allows you to choose, it allows a business or end user to choose the leads that they're interested in, the region they want to look at, the date range they want to look at. And then you can add in the external data you want to, like websites that were visited or other interactions that might be custom to your business. And it will return to you some summary statistics on those leads. And also it will run the leads through the machine learning model and say which ones look like good leads and which ones look like bad leads. And it can also tell us why. So this is what we're going to be looking at today. All right. So before we get too into lead scoring, though, we're going to do a quick overview. So welcome to the H2O AI Hybrid Cloud. At the end of this presentation, I will show everyone how you can sign up and you can get 14 days free trial access to try everything we're going to look at today and more. Essentially, the AI Cloud is a couple components. First, we have an app store. The App Store comes with data science best practice apps pre-populated. This includes model building with Driverless AI, but also data science best practices like model validation, which helps you answer the question, is this model ready for production? And model monitoring, which helps you answer the question, this model that's in production, should it still be there or is it time to retrain? We also have apps like H2O Auto Insights, which is another horizontal solution where you can upload a data set and it will tell you It'll basically do exploratory data analysis for you. So it will tell you if there's text data, what types of topics or sentiments in your text. For data, it will show you trends over time and if there's any outliers. It'll find outliers in general in your data set and show you any correlations. So the types of exploring you're probably doing by hand with code today is done automatically. In addition to having our data science best practice apps, the AI App Store comes with some example vertical solutions and allows you as a Python developer or data scientist to build your own AI applications. So we'll look at an example application for lead scoring today, but essentially we're able to build front ends for any of our machine learning models. So now that we have jumped and talked about the App Store a little bit, two more things I want to mention. So we're going to go into the driverless AI application, which will allow us to actually start building our lead scoring model. And then we also have access in the AI cloud to MLOps, which allows us to host models and use them in real time for predictions in any of our AI applications. So I'm going to jump into driverless AI. And we're going to talk about how we can use AutoML to build a lead scoring model. All right, so what just happened? The H2O hybrid cloud, for any of my more technical people on the phone, it is able to run in any cloud or on-prem. It does have a Kubernetes requirement. So what just happened is I said I wanted to use driverless AI, and the backend went ahead and spun up a node for me. It was already running, and so it redirected. And so I'm now in my own private instance of driverless AI, where I can upload my own data sets, I can build experiments, and I can push those experiments into production. So here I have a couple data sets I've uploaded ahead of time. We're specifically going to be looking at the lead scoring. And so these are my explicitly good or bad leads from the last couple of quarters. I can use details to look at my leads. I can see all the columns in my data set, and I can explore my data, see if there's any missing values. For any of you that are doing lead scoring today, you probably have a lot of missing values, things like customers who don't update maybe what their title is, or they don't include all their information. Missing values is totally fine when we're doing automated machine learning at H2O. So just to mention it again, here I have a column that I created based on historic information, good leads versus bad leads. So good leads is a 1, bad leads are a 0. And again, good leads are ones who became customers or MQL'd or SQL'd, and bad leads are spam, do not call or disqualified. And this is anonymized data, but it's based off of what you would see in your CRM. All right. So I did upload my data ahead of time, but just to be really clear, we have, there's only a couple on this specific system. We have over 15 connectors at H2O, so you can pull your data from wherever it's living. We can upload our, say, Salesforce data, or we could use Python to pull it directly. We can upload data from any SQL database. And again, we are talking about lead scoring today, but like we mentioned at the beginning, in general, machine learning tends to be industry and use case agnostic. So we could do any type of which one or how much question. We're just focusing on which leads are good and which leads are not good today. All right. So after I went ahead and viewed my data set, I could split the data set into a training and a testing data set. And this would allow me to make sure that the model I build on some data actually performs well on new data it's never seen before. Now, I already have an outside test data set, so I'm not going to worry about this, but it's nice to know you can do it directly from the UI. To start building our machine learning models, we're going to use the predict button, and this is going to take us to the experiment setup page. Here, I have to tell driverless what I want to predict because at this moment, we're solving just those supervised problems, the which ones and how much. So I'm going to say I am trying to predict if something is a good lead or not. Based on this information, it's went ahead and set some suggested settings for me, which we'll talk about in detail. At this point, I could launch an experiment and start building machine learning models automatically, but we're going to talk a little bit more about what's going on here before we do that. So if I zoom in to the left-hand side, I have a summary here of everything that's going to happen when I click this launch experiment button. So essentially, this is going to be automated machine learning which is going to try to find for me the best lead scoring model based on my historic data. This isn't just going to be sort of a leaderboard approach where we build a couple different models and compare them to each other. We're actually going to do that process over and over and over again with a genetic algorithm on top that's learning what's working and what's not. So we're going to do many, many iterations of a competition. And then at the end, we're going to get the best model or ensemble of models for the specific use case. So I can see here the types of algorithms that are going to be tried automatically. A simple decision tree, which is really explainable, but not always super accurate. We have light GBM and XGBoost. These types of tree-based algorithms can be really easy to explain and also are pretty highly accurate. And then we have information here that says 3-fold cross-validation 2 reps. So essentially, driverless has automatically seen that this is a pretty small data set. Usually with machine learning, we would want to put in as much data as possible. We intentionally only used a couple quarters of data because our leads are going to change over time. But because it's a really small data set, it's going to do a lot of cross-validation, which is essentially building the model on different pieces of the data and then aggregating it all together. And that makes it more likely that the model will perform well on new data it's never seen before, rather than overfitting. And just for anyone that's not familiar, overfitting is when you make a model that looks like it's performing really, 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 really well, and then you put it in production and it actually does terribly. So it basically memorized your original data and can't handle new data at all. So because of the size of our data, it automatically turned on a lot of cross-validation, which is a nice feature. So if we scroll down a little bit more here in the interpretability section, it talks about feature engineering. So when we talked about the common workflow for a data scientist, one of the main steps was going to be that feature transformations and feature engineering phase. So essentially you take your raw original data and you massage it to get more information and to make the data actually usable by machine learning algorithms. In driverless AI, this is done automatically. So I can give it my raw text, I can give it my dates, and I don't actually have to prep those for machine learning algorithms. It's just done for me. So with my raw text, this is going to do things like some of the state-of-the-art NLP algorithms like Roberta and so forth. And for dates, it will do things maybe a little more simple. We can extract the month out from the date and see if that's predictive or not. So those are sort of like feature engineering for data types, but we also are going to have feature engineering that helps us understand how our different columns interact with each other, because maybe one column is not very predictive by itself, but when you combine it with several other columns, it becomes interactive, or it becomes predictive. So this is done through creating new features by clustering columns together, creating new features by adding or subtracting columns, and all of this is going to be tried for me automatically. I'm going to zoom out. Here we're going to see 3 dials that allows me to say, as a business user or as a business expert on this use case, what is most important to me? If I raise interpretability, I'm going to see that the types of engineered features is going to be reduced. So we're only going to have new engineered features, which are really easy to explain, like extracting out your month from date or adding and subtracting 2 columns. We're not going to have the more complicated features, which can be really performative, or that can be really good at increasing model accuracy, but they're not so good at being explainable. Or we can reduce interpretability and saying that it's okay if my model is a little harder to understand, I really need accuracy to be high. So as we change these dials, we'll see the change of plan on the left-hand side. Something else I wanted to point out, 2 more things. The next is we can choose what scoring metric is most important for our use case. So based on the data size and how imbalanced it is, a metric will be chosen automatically. This is a really balanced data set. It's like almost 50-50. But rather than AUC, I might do something like F1 score, or I could use F2 score, which tells me that like recall is more important. I really want to catch every possible good lead. Or I could do F0.5 score, which should say precision is more important. And I really want to be accurate when I tell a salesperson it's a good lead. So this is, again, where understanding your business problem is really important, because you want to optimize for the right metric. We need to be able to tell the AutoML what makes one model better than another model. All right. And for any of my expert data scientists on the line, either who are using AutoML today or they're a little skeptical of AutoML because you really like to have your hands in the weeds, I want to show you the expert settings. So we'll not go through all of them, but essentially here at H2O, we want you to be able to have full control over your model building experience. So you can make any changes to the experiment, whether or not you want there to be a production ready pipeline at the end. You would want a production ready pipeline if you're going to productionalize the model, but it does take time to build it. So maybe you want to turn it off if you're just testing. You can get really detailed on all the models. You can turn on or off specific models. So you can say, actually do not want you to try XGBoost. No matter what, that's just not going to fly. Or you can say, I absolutely want you to try XGBoost. And then for each of these models, you can also get really into the weeds on some of the hyperparameters. So if you want to use a specific learning rate, or for your GLM, if you want to use you can use different learning rates. Anyway, you can get into all the weeds for all of these as needed. So it's not required. There are sort of best practices from our Kaggle Grandmaster team here, but if there's anything specific that you need to do for your use case, you can, and you have full control. All right. So I'm going to go ahead and hit launch experiment, and we will start building some machine learning models. Okay, so while this is running, a couple things are happening for us. First, you'll see at the top above this little wheel that we're doing a lot of checks. We're checking the format of different columns. We're also going to do some like guardrails, data science best practices, like we were talking about earlier in our slides, such as checking for shift or leakage. So leakage is essentially where you have something in your data set which looks really predictive, but then you use it in production and it was actually basically cheating. So if I were to include, like, one of the default columns from Salesforce for example, would be a close date for customers. If I were to include the close date in this model, it could just cheat, and it could use, if there's a close date, it would say, yes, that's a good lead, they're going to close. And if there's not a close date, no, that's a bad lead, they're not going to close. But we're not going to know that ahead of time, right? We would only know that after they close. So this is where you want to be really careful when you're prepping your data, but it will check for you automatically. So if there's anything too fishy or too predictive, it will give you warnings, which is really nice. All right, so I'm going to go to the notifications. We can see some other notifications. It automatically dropped one of our columns called type, because they all had the same value. That value was lead, but it's not very predictive if every column's the same. So it's going to just drop that for us automatically. It also saw there were unique IDs for email and URL. So those are going to be dropped too. We wouldn't want to include unique IDs when we build a machine learning model, because then you would just be memorizing which users did which action. So really, as a data scientist, I should have removed those myself, but I got my guardrails up, so it caught it for me. All right, so let's close this. So we will start to see some models pop up, but I'm going to go ahead and jump into a completed experiment and to show you what that looks like once it is done building. Okay, so this is a model I built a little bit earlier. It ran for about 35 minutes. And in those 35 minutes, it built over 500 models, which all competed against each other. It also, in the process of building these 500 models, it built almost, let me find the number to make sure I don't exaggerate. Here we go, 949. So it tried almost 1,000 new engineered features to find the best ones for this specific use case. If I look at the left-hand side down here, all of these little yellow dots are models that were built. So we read this chart from left to right. And in this case, we're optimizing for F1 score, where 1 is really good and 0 is really bad. So we can see these are getting higher and higher over time, which is a good thing. Basically, our genetic algorithm was learning what works for this data set and what doesn't work for this data set. So again, the genetic algorithm is basically like machine learning for your machine learning. It's learning what type of models are good and what types of features are good. I can hover over any specific model, like this one, which didn't perform as well. I can see that was a light GBM, that's the algorithm. And then in the center, I can see the most important variables. So for this specific model, the country of the customer or of the prospect was the most important predictor. And then the number of employees was the second most important feature. And then taking the created date and extracting out the day was also really predictive. So we can see some engineered features coming out. If I go to the final model, which we're going to actually use, this is the best one, it's the most predictive. I can see this is an ensemble of two models, a light GBM and an XGBoost together. So essentially we found that just one model by itself wasn't as good as automatically combining these two models together. In the center here, we can see our most important features, and we'll dig into these a little bit more when we talk about interpretability, but I can see that grouping together interactions between the size of the company, the source of the lead, and the geographic region, that was most predictive. So I didn't have to, as an end user, sort of play around on my computer and try new features and see that those three things together are really important. It found that for me automatically. So I now know that the interaction of those three things are really important. You'll see weight of evidence above that. That's a type of feature engineering where you're looking at the ratio of good things versus bad things, just for anyone who's interested. All right, so once we went ahead and built our model, there's a couple things we could do. One, we could provide a test set and we could see that this score, 0.86, we could see if it performed as well on the test data set. We would want to know if our model was going to do good on new data. We could also go and look at the machine learning interpretability, which would help us understand how the model works. But first, I'm going to download the auto report. So this is a Word or Markdown file that you get automatically every time that you build an experiment. So I'm going to download this file and look at it at my local machine, but a quick plug for the App Store. We won't look at it today, but one of our core service applications, data science best practices, is actually an AutoDoc app where you can manage all these auto reports that we're going to be looking at for all your different use cases. So we'll just do it on the desktop today, but just to keep in mind what's available in the App Store. Okay, so what is this document we're looking at? Well, this is a 52-page report that explains to us what happens in that 40-minute experiment that we ran. This comes out of the box. It can be customizable for your specific business or use case, but it essentially goes through things like the methodology. How did we go through and build models? Did we do any data sampling? Well, in this case, we only had 4,000 rows, so there was no sampling. But if you had hundreds of millions or billions of rows and you did a really low accuracy on your dials, it would do some sampling. It would explain to you how that worked here. Let's go back to the top instead of clicking. It goes through final and alternative models. So what models did we try that didn't work? Why did they not work? It goes through the feature transformations. What are the features in our final model? What's the math behind them? How does it work? So anyway, we're not going to go through all 52 pages, but the point here is that it's pretty common in data science projects to document your work as you go. Not only do you have to explain how your model works to business people, usually, but they're often, if you're going to productionalize a model, you need documentation on how it was built, how to maintain it, what you tried that didn't work, and what you tried that did work. And this helps people that come and work on the project in the future. It helps yourself when you come back to a project in 6 months. And in general, having the auto documentation as a starting point. I mean, this is a Word document, so I could add a new section that explains the business use case or add notes, can be really helpful for model documentation understanding. All right, so we're going to get we're really close to looking at our front end, our custom front end for lead scoring, but let's talk a little bit more about machine learning interpretability first. So one of the main things for our lead scoring use case is not only do we want a model in production where we can give it new leads and it will tell us if they're good or bad, we actually want to understand our data. We want to know what about a person makes a good lead and what about a person makes a bad lead. This helps us both as data scientists and business users validate and trust the model if any of the rules are intuitive or if they're not intuitive and we want to kind of take a step back and make sure this is something we want to use. Also remember, we talked about how lead scoring is often done with a rules-based approach. You get points for some actions and lose points for other actions. By focusing on the machine learning interpretability, we could actually get new findings here and create new rules, new manual rules based on what we found with the machine learning. So there's a couple of things we'd want to do and reasons we wouldn't want to just productionalize the model, but actually explore and understand how it's working too. So here we see there's going to be 12, I think, different types of machine learning interpretability. For time, we're going to just talk about a few of them, but we do have a full tutorial on all of these on the website, which I'll link to at the end. So first, let's go ahead and look at our transformed Shapley. So for anyone that's not familiar with Shapley, Shapley values are a way of telling you which features contributed the most to predictions. This comes out of game theory, but essentially the description feature, when we run weight of evidence on it, is one of the top contributors to our prediction. And then we see that country and a combination of the employees count and the industry are also really high. And this is all well and good, but where Shapley gets really, really powerful is at the individual level. So here I can search for a specific row in my data set, the first person, and I can see whether or not my model thinks they're a good lead and why. So here I see all the gray bars going to the left, which means they're bringing that score closer to 0. So for different reasons, we don't think this is such a good lead. The strongest reason is this specific rows combination of customer size, industry, and primary product. So we don't yet know what about that interaction makes this person look like a bad lead, but we do know that this types of value is what's really strong. I'm going to go to the next page and I'm going to show you that this person does have some features that make them look like a good lead. So the combination of the product that they're interested in and their region make them look like they're a good lead, but they have so much pulling them down that if we were to do an ordered list of customers or prospects that our sales group should go prospect, this person would be probably, you know, towards the middle or bottom. But this means for each individual row that when you go ahead and tell your sales team, hey, check out this lead, it looks good, you can tell them the ordered list of reasons it looks good. This lead looks good for this reason or this other reason, and this can help your sales team with the strategy for approaching different leads. All right, we're going to jump back and then let's talk about one more. This is going to be partial dependency plots. I'm going to hit clear to get rid of row 2. So partial dependency plots are basically a way of saying if I were to keep everything about my, oops, sorry about that. I'm having issues with the Zoom. There we go. If I were to keep everything about my data the same, except for one feature, if I were to change one feature, how would my predictions change? So our predictions on the y-axis are going to go from 0, which means they look like a real bad lead, to 1, which means they look like a really good lead. And then we have different features on the x-axis. In this case, it's size of the number of employees at the organization. So regardless of anything else going on with the person, on average, if they're a large organization, they have more than 10,000 employees, our model thinks that they're more of a good lead. We have a lead score of 0.6. That's greater than 50%. So that's pretty good. Whereas if it's a really small lead, small company, only 1 to 10, our lead score is much lower. It's at 0.4. So this is partial dependency plots are a way for a more technical person to understand how different features can have an impact on predictions. So I changed just this one feature. I look at just big companies versus small, and I have a drastic change in predictions. I can choose the feature I'm interested in. So I can look at, say, let's do the source. That's a good one. Where did the lead come from? And here, what I found is there's not necessarily anything really surprising here, but it can help us understand and sort of trust or validate the models on the right track. So I can see that one of the highest predictions for the lead source is manually created, which makes sense to me because if a human's already looked at the lead and thought about it and created it, it's probably more likely to close. There's already someone thinking about or talking to them, so forth. Whereas some of our more automatic generated leads might not perform so well. So in addition to manually created, we see also that direct leads or someone submitting a form tend to be more likely to be good leads according to our machine learning model. And so we'll stop exploring at this point, but essentially in our machine learning interpretability module, we have a way to really understand how the model is working, which can help us understand how the data is working. And we won't dig into them today, but I do want to point out we had some text data. Specifically, we had a description, and also the lead could provide information from a form fill. So we do have explainability for text as well. We can see the tokens. It's not exciting in this model, but we can see the tokens and text that are interesting for our data set. So we'll pause there. All right, so I'm going to go back to my experiment. We have this one running. We have our good lead score. So we've built a model. Now, what do we want to do with the next? Well, a couple of things. We've explained it. Let's say that we're comfortable with this model and we're ready for our business end users to start interacting with this model, however they might interact with models. So what I'm going to do is go into projects, which is a place for me to sort of organize my work. And I created a project called lead scoring. And this is where I could add any of the models that we built around lead scoring into this project. As a data scientist, I'm going to sort of hand this off now. Depending on your organization side, maybe the data scientist does the step first or as well, but it might also be more like a ML ops or operations team. So all the data scientist has to do is put their model in this project. I'm going to switch personas now and be your model operations person from the AI cloud. I'm going to go into my models, which shows all of the models that I have access to that are ready to be productionized. I see the same projects that I saw in driverless AI as a data scientist. And here I have my lead scoring model, which was added by my data scientist. And I went ahead and put this model into production. So what this means essentially is this model endpoint is sitting in the ether and it's waiting for new data to come to it. So we're going to look at a front end, which actually downloads new leads and it sends all those leads to this model. It gets predictions back. For my more technical audience, this is running as a REST endpoint. I can show a sample request. So essentially, we're going to be sending data in this format to the model, and we're going to get back predictions. If we needed real-time predictions, we could get them. We can have sub-millisecond or sub-second latency. But in this case, speed is nice, so our sales people aren't waiting for a long time, but it's going to run pretty fast. So we won't get too much into ML ops today. I want to talk about our front end we're building for the specific use case, but I just wanted to point out how this model is being used, where the model's living, and that there is model operations functionality. Our model operations person would also use like model monitoring to understand if the model was still healthy, if the predictions looked like they were still good, if there was a drastic change in the type of data, and they would be able to alert the data scientist into when it was probably time to retrain their model. So we'll close model operations for now, but that work we just talked about, the understanding if models are drifting or anything, that would be done with model monitoring. It could also be done some with our model validation, data science best practices. But let's get into our front end for lead scoring. Okay, so here's what I want. So before we jump into this, I want to give you a little bit of background on H2O Wave. So we talked about this earlier, but Wave is a Python library that allows you, and it's available in R soon too, but it allows you to build front ends without having to know front end development skills. So your data scientist who mostly only knows Python or maybe R, doesn't know JavaScript or CSS or HTML, they can build front ends now. So this is an example vertical solution that we built for doing a whole customer journey, but lead scoring as well. But it is just an example. So we'll talk about this a lot while we look at the app, but everything about this is customizable, from the color of this little icon here to the location of all these cards to the words that we are looking at. And we'll actually together in a few minutes change this app and redeploy it and see how easy it is to actually start building and modifying these apps yourself. But let's go through a demo of the app first. So we talked to our end user about the workflow that they needed and how they wanted to interact with this model. So there's a model running in production, but we need our end user to actually get predictions or information from it. So now I'm no longer a data scientist or my model operations person. I'm my business person. I might be a business development representative, or I might be a salesperson, depending on the day. But I'm going to say that I want to go to the leads dashboard. It's going to make sure oops, sorry, there we go. I'm gonna say I wanna pull new data and create a new dashboard. I don't wanna look at one of my past dashboards. First, it's gonna make sure that I have permissions in this company to see this data. I do, so I'm gonna log into Salesforce. I'll say next. And then I'm gonna tell it the types of leads that I wanna look at. So is there a specific date I wanna start at? And is there a max number of leads that I'm interested in? And I'm gonna anonymize the dashboard today. So it's gonna be somewhat fake data based off the real thing. But I could change, if I wanted to look at several weeks of data or just 2 weeks of data. And then I can choose what regions that I want to add. Again, the layout, everything here is fully customizable. So I'll say that EMEA and North America work. I could add an additional data. So this is going to be really specific to you and what data you have at your company. Here you'll see aquarium usage report. So at H2O, we have a tutorial training center called Aquarium, where anyone, including yourself, can sign up and have hands-on labs for running driverless AI or learning about open source machine learning building. And we could include that information because if someone's doing all your tutorials, they're probably more likely to be a good lead. So I could say, I want to bring in this third-party information. I'm not going to right now, but we could. And so then we'll go ahead and pull the data. So right now it's going to Salesforce, but again, it could pull our website or aquarium data too. And it's preparing a data set. It's going to show us a dashboard summary overview of what's in these leads, but then it's going to also run all those leads from that model that we looked at in production and give us predictions on which ones look good and which ones look not so good. All right, so we got our dashboard. That ran pretty quick. So here we don't have predictions yet. This is just based on this is dashboard of the data. So in this time frame, we see about 2,400 leads. 100 of them already are themselves. They have labeled themselves as good leads based on historical rule information. So we looked at a rules-based model. They've got enough points. And then we have a little under 200, which are bad leads. So they've, unsubscribed, they've been disqualified by our experts or their spam. We have a couple different types of charts or plots, which might be interesting to our business users. Again, everything here is fully customizable. So you might say, I want this chart to take up the full space, or maybe I actually don't even want to include it here at all. And we will look at some of the Python code to make this app shortly. We can see the breakdown by country. We can have third-party integration with plots. So we have a third-party integration with sort of a map plot, probably using Plotly. And here we have a word cloud. We can see when the leads came in, and we have other sorts of information. So we talked about this earlier, but I'm just going to iterate again. This is not like a hosted lead scoring model where everyone would use their data. This is the ability for you to build your own. H2O, we have maker culture, and we provide the tools for you to build your own machine learning model and build your own front end, or use this as a starting point. But essentially, you would have different columns or different data, maybe different plots that are interesting to your end users. But my point is, we're not getting too in the weeds of what makes a good lead right now or what the leads look at. We're looking more at the art of the possible and how we're able to build these custom dashboards and interactive dashboards. All right, so now I'm going to jump into a prediction dashboard. This was all descriptive, historic information that we already knew. But now let's get into our predictions. So it's broken up by region in this case, and we can see how many leads come from this specific region and what the average prediction was. So remember that a prediction of 1 means we really think it's a good lead, and a prediction, oh, great, the curse of the live demo. A prediction of 0 means that we really think it's not a very good lead. So we saw that the average lead was about 7.79. And that means that actually our leads are looking pretty good on average. So we'll let this run one more time. But some of the information we'll see in this prediction, we'll have a list of all the leads. We'll have integration to Salesforce, so I can click on one of the leads and go directly to my information on my CRM. Here we go. I can see the distribution of leads by different geographic information. Something that those of you with CRMs probably know, we can see the complete list of data. So a lot of missing values or nulls in our data set. Maybe customers didn't fill out value or we don't have website information for them, but we're still able to make predictions with what we have available. And then here I can see that we have a lot of leads in this case that are a couple weeks old, but they have a really high lead score. So in this somewhat simulated data set, I would tell to my team, hey, these are leads we want to focus on. Here we have a distribution of our predictions. So we can see that there are a handful of leads that have a very high prediction. They look like they're going to be good leads. We have a handful of leads with really low predictions. They look like they're going to be spam or disqualified. And then we have a smaller number of leads in the center. So this is where we would sort of suggest starting at the green and then getting into the purple ones. We'll see a lot of the really good leads will match up with our traditional rules-based approach, but maybe some of these other purpler ones that are potential good leads could end up qualifying really nicely. All right, and then we're gonna skip the summary, but basically the summary would go ahead and give us an overview for every company of how many leads they have and if they look good or not. All right, so this is an application that I have running today in our H2O hybrid cloud where you can log in and try your different applications. But I want to talk to you about how you can start building applications yourself. So we're going to open up a new tab and we're going to go to wave.h2o. So Wave is our open source front end for actually building these types of user interfaces so that your business users can start really easily interacting with your models. If you go through, there's a lot of examples and tutorials for how to get started and start building your apps. So this is a nice place to learn a little bit more, but I'm gonna now open up some code that I have running for this specific application. So I have, Wave is done, there's basically a backend server that runs and then app code that tells the server what information to show. So I have the server running on my local machine and this is the code that I'm running and I can actually open up my app code and I'm going to, this title here, I'm gonna go ahead and just change the title. So in my code, I have a Python library called H2O Wave and it has a UI object. So I'm gonna have, this isn't exactly where I wanna be. What is it called? It says customer success, here we go. So I say, H2O, H2O Wave, I want you to make me a header card. I want it to be at the top of my screen and I want it to say customer journey AI for demo. I'm gonna just save this and I'll go back to my app and I can see that I already changed that. So this was all done with Python and we do have more in-depth tutorials. I'll talk through like how to build apps, but we have a really wide variety of audience today, so don't get too in the weeds. But just want to show you how easy and quick it is to use these UI objects with Python to change the location of card, to change the contents of cards. It's all done with Python and it's really straightforward to start building your own apps. All right, we're gonna open up to questions really soon, but there's one or two more things I wanna touch on. Just to be really clear, we looked at one example of a vertical solution app. And again, it's fully customizable, but I wanted to show an example of a different app just to give you a sense of how the UIs can be very different. You can show lots of different types of information. So this is no longer lead scoring. This is for a different type of use case where it's going to be focused more on machine learning interpretability, which we looked at in driverless AI, but for more of a business user. So the use case here is on predicting which employees are likely to leave their company or not. But we have a completely different type of dashboard than what we saw in the lead scoring. And again, everything's fully customizable, but we can see the likelihood of departure. This plot is going to be somewhat similar in our lead scoring to the prediction distribution of leads, where we had a lot of good leads and some bad leads. But here we can see the likelihood of employees to leave. We can see which features are most important. So we can see that employees that do a lot of overtime are more likely to quit. And we can also see a breakout of specific types of employees and which ones are more likely to churn than others. There's also an ability to look at individual employees, click on a row and get those positive and negative Shapley values that we talked about earlier, but shown in maybe a more business friendly and less math focused front end. So just a quick example that there's a lot possible when you're building front ends with Wave, and to build these dashboards or interactive applications, you can build exactly what you need for your end users to interact with your AI models. All right. So I wanted to talk about how you can get access to what we looked at today. How you can get access to the H2O AI Hybrid Cloud. So we'll take a minute now for anyone that wants to sign up. You can go to H2OAI/free, sign up using a corporate email address, and this will give you mostly instant access to the AI cloud. You will have to go to your email and always check that spam folder to actually create a password. But when you make an account, what you'll have access to is our AI cloud, the core service applications like Auto Insights, where you can upload a new data set and automatically find information like outliers or topic modeling. You can build models with driverless CI, just like we did today for lead scoring and for other use cases. And you'll also have access to many demonstrator applications that give you ideas of the vertical solutions that you could build or use for your machine learning models. So again, here's the link. It's H2AI free to sign up and actually get access to the full AI cloud. To learn more, we have some links. I believe that will be shared with everyone at the end. You have access to all the documentation that explains how the AI cloud works, but also information on how you can start building your own applications. So we have source code for example applications. We have a lot of app tutorials in the Wave docs that I talked to you about. And also for those of you that really want to get hands-on and start building an app, we recently did a hands-on live coding session on how to build apps that's really focused on actually writing code. So you're more than welcome to go check that out as well. And then I just wanted to invite everyone to join our Slack community. So you can have direct access to the makers at H2O and our awesome customers and open source users who are always using our products in really interesting ways. So you can join up at H2AI/Slack community to join. But I'm gonna kind of pause now. There's some more things we could talk about with lead scoring and details, but I want to pause for any questions.
How easy is it to have a real-time endpoint application integrated with something that's going on a H2O dashboard once I already have some kind of prediction model created?
Yeah, great question. So it's not in lead scoring, but I'm going to go ahead and show a different application. It's an example of real-time predictions. So here is for customer churn. So we're essentially looking at, we again have a model that's hosted in MLOps like we looked at. And this is a model built on open source data for which employees or which customers are likely to churn or not. So this application is actually reading real-time prediction or real-time data from customers who would call into customer support. Their data is sent through the app to the MLOps model and a prediction is made. So here the dashboard is going to be updating automatically every couple seconds with the latest information, but we do get our predictions in near real time. So you would get to choose how to present this information to your end users, but we can see that the model is constantly updating. So in our historic data, we can explore that historic data, but we can see that we have a couple customers here who have a higher churn likelihood. We could go ahead and click on a specific customer to learn more about why they're churning, but we do have ways to integrate and actually do real-time updating dashboards. Did that help answer the question or did I miss?
No, it does. Thank you.
Perfect. Great. Other questions? Nothing. All right.
Maybe it's just a little information overload.
Yeah, it
Or
is a lot. It is a lot. All right, we have
it's a
a
really cool
question.
dashboard. Your presentation was fantastic. It's really good to see a lot of these things explained. I joined in 20 minutes late because dumb me didn't look at the Zoom link. I was just
Oh
waiting for
no.
something to show up. But when I joined, and then since I've been able to follow pretty thoroughly, I'll just look back at the application, the video if it's available later on, and the free trial link, and just give it a shot, and maybe use YouTube or any other resource. I'm pretty sure the H2O website has tons of other resources to just teach yourself DIY.
Absolutely. And we're always here to help. But definitely join the Slack community. I do see a question in the chat. So this is a great question. Is there room to plug in custom model selection for the Wave applications? And absolutely. So I'm going to jump into this custom return, the real-time dashboard we looked at, to look at the app code really quick. So the H2O Wave apps, it's open source again, building the apps, not hosting them in the iCloud, but building the apps is open source. And it's all just Python. So if you wanted to use a custom SVM model, if you wanted to connect, if you wanted to build a model and say scikit-learn, of course at H2O, we think that our model building products are pretty good, but there's times when there's other things you want to use. So you can fully integrate to anything that's available in Python and R. So in this case, I'm using a couple of other libraries, pandas and NumPy. I am using models built by driverless AI, but I could connect to other models if I wanted to. But again, to actually build the front end, Wave is just really focused on building the front end pieces. So in this case, I have a UI separator that says the word overview, and that's this little guy right here. And then there's a button that says about this app here. So Wave doesn't care what the back end is. You wouldn't even have to make an AI app. You could use a front end for other types of apps as well. But yeah, I probably overly answered that question. I've seen more questions in the chat. So I'm going to just read through them. Someone says the recording would be helpful. Great. I believe, so Rachel started recording this. I believe it will be provided. I'll let Bruna or the AI4 team share how it will be provided.
We will be sharing it on our YouTube channel.
Oh, perfect. That's great. Yeah. Thanks for the feedback, Jeff. All right. Oh, this is a great question. Is there a way to incorporate human hard-coded rules in the training process, such as if the dollar amount exceeded a certain amount, then ignore the field? Or can this be done in the processing you're preparing? This is a great question. So some of it can be done in your machine learning step, and some of it would have to be sort of rules in your pipeline or in your Wave application before or after. So I'm gonna read it one more time before I try answering. Yeah, so for some of the specific rules, like if their dollar amount exceeded a certain amount, then ignore field. So something like that would be a data pre-processing step, or you might actually incorporate your those rules afterwards with your predictions. So for example, in this application, I talk to MLOps, I give it data and it gives me back predictions. I could take those predictions, and before I just show them raw to the screen, I could add a couple more rules. So I could say if the prediction's greater than 0.75 and some other business rule, like one of the input fields is less than a certain dollar amount, then show this value. So some of those rules would have to be incorporated into the application rather than just the machine learning model. Hopefully that helps answer that question a little bit. Oh, thanks for the nice feedback, folks. Please ask other questions if you have them, but we'll be here. I think we have 15 more minutes. I didn't want to overwhelm with too much information, and I was expecting a few more questions. We'll switch dashboards so it stops flashing at us. All right, are the insights created automatically for the business questions? That's a good question. So there's kind of. So there isn't automatically, right now, there's not an automatic way to sort of have a, to like type out a business question and get insights for it. Machine learning is great and AI is great, but there's a reason that data scientists exist and are involved with machine learning models. And that's sort of the human interaction and being able to communicate with your business user to really understand what they're trying to solve. So that's sort of my vague no. However, if we look at auto insights, which maybe we have time to look at, we have screenshots here now. I'll go ahead and start this. It will take a couple minutes to get a node for us and spin up the instance. But essentially, in our Auto Insights application, it allows you to upload a data set, and then it provides back to you both pictures and text-based insights. So it's not based off a specific business question, but you wouldn't need to prep your data the way we talked about for machine learning, where we had to think about the exact business case, and we had to decide if we wanted to call a yes or no based on this rule or this other rule. You could just do your raw data and get straight business insights from that. So we'll still give this a couple minutes to load, but hopefully that helps with that question. There does need to kind of be a human involved for understanding the business questions, but you can get automatic insights without having to manipulate the business question into a machine learning problem per se. That was wordy. Sorry about that. We'll give it just a minute. Great. All right. Well, I know there is lots of other presentations. There was a lot of things you could have watched during this hour. So I'll stay on until we hit the 1:30 time. If anyone has any other questions, you can do questions in the chat. Also feel free to do audio questions. But thank you for your time, everyone. And thanks for joining us to talk about lead scoring and how to build machine learning models and build machine learning front ends.
Hey, Michelle, can you talk a little bit about how people get started with the trial if they didn't sign up during this?
Yeah, I see. So that's a great question. So when you sign up for the H2O hybrid cloud, actually, let me share my screen. I'll just put the link up again. So there's a couple things that you can do. The first is that you'll receive emails sort of explaining to you how to get started. So telling you how you can build a model. We'll point to demo videos similar to today's, but maybe a little less technical, that show you how to start building models. I would highly recommend when you go into the tutorial or into the AI cloud, there's a trial tutorial button, and this will basically, this is a 4 or 5 page tutorial that walks you through how to get started. So it does what we did today at a more high level. So how to connect to driverless AI, how to build a machine learning model on a sample data set, and how to use an example front end for that data set. So that is where I would start in your trial, is looking at the tutorial. But then once you have a feel for how it works, you can start looking at different apps. So you can upload your data into Auto Insights and find new findings about it. You can use, once you've built a model with driverless AI, we can use the model validation for my more technical people on the phone that helps you understand if a model is good or not. So this runs statistics. Machine learning interpretability helps you understand like how a model works. Validation is going to run statistical techniques to understand basically if a model's good. So there's lots of different core services here, but that's how we would get started. Thanks for asking, Tara.